Okay, so number 15. Shh. So one thing you want to do here is draw a diagram and put all the data on the. If you try to do a problem like this without keeping track of the data on a picture, it's much harder. So let's talk about the temperatures. So you're going to have to look up specific heats. You got to look these specific heats up in the book. You don't have to memorize them. I'll give it to you on the quiz or the exam. Okay, so temperatures. So we're told that the silver starts at 87 degrees Celsius, so like right up there, and then the water, the aluminum, and the copper start at 27 degrees Celsius, and then they come together, and then everything meets at 32 degrees Celsius, which is called the equilibrium temperature, right? So the silver is cooling. So what's the delta T for the silver? The silver goes from 87 to 32, so that is negative 55, right? So we can put that in here for the silver. Delta T1 is negative 55. And then the water, the aluminum, and the copper warm from 27 to 32. So the delta T for the water, aluminum, and the copper is positive 5. So we can put that in here for the copper. So delta T2 is 5. Delta T3 is 5. And then delta T4 is 5. So there's all the data. And what we're looking for is the mass of the cup. What must be the mass of the aluminum cup? All right, so I'm going to erase the question so I have some room to solve this. So we've got everything we need. Now, what's the main idea for a problem like this? The main idea is heat loss equals heat gain. In this problem, which object is losing heat? The silver. The silver gets dropped, the hot silver gets dropped into the cool water, which is also in contact with the copper rod and the aluminum cup. Hey, one thing I want to mention here, the water, the aluminum cup, and the copper, even if the problem doesn't tell you so, they all start at the same temperature because they're in contact with each other, right? Sometimes the problem won't tell you that, but if the problem starts and objects are in contact with each other, the objects that are in contact are all at the same temperature, okay? So the main idea here is heat loss equals heat gain. The object losing heat is the silver, so I'm going to say negative Q1. The objects that gain heat, it's all three of these. We have three objects that gain heat. So it's going to be Q2, Q3, Q4, where Q is heat. So all we're saying here is the heat lost equals the heat gained. We have one object losing heat, three objects gaining heat. Now, there's two equations for Q. We got Q equals MC delta T, and we have Q equals ML. Which one applies to this situation? The MCAT. This one applies. When do you use Q equals ML? That's for phase change. That's if you have a phase change. This problem has no phase change. Okay, so it's MC delta T. All right, so this is going to be, now look at, you know what? What I recommend doing is absolute valuing these heats. Unless, what's up?
Can I go? I need to play the Spanish music.
Oh, okay, you can go. Yep. All right, what I recommend doing is absolute value the heats unless they're asking for the equilibrium temperature. If they're asking you to solve for the temperature where all the objects meet, then you have to leave this minus there, okay? But unless they're asking for that, just absolute value it. So we're going to say the absolute value of the heat lost, M1C1 delta T1, is going to equal M2C2 delta T2 plus M3C3 delta T3 plus M4C4 delta T4. The only thing missing, the only thing that we don't have in this equation is M4. That's it. Okay? So I have this already calculated. when you plug the numbers in, I'm not going to bore you by having you watch me plug it in, but this value here comes out to be 5,148. This one comes out to be 77.4. This one is 4,709.25. And then this is 4,500 times M4. So you take this, equals, plus, plus, solve it for M4, and you get 0.08 kilograms, which is 80 grams. That's the answer.